Okay, I'm going to show some examples of solving a system using adding and subtracting. If you look at this system of equations, a system is two equations with two unknowns. Sometimes you'll have a system with three unknowns. In that case, you will need three equations. But for what we're doing, two equations, two unknowns. So one thing you can do with the system is add one equation to the other. So I'm just going to draw a line here and add. And when I do, I get 5x plus 0y. I'm not even going to write that. So 5x equals 15. Now I can solve for x. I can divide both sides by 5, and I can get x equals 3. I have the system almost solved. I still need to get the y value. How do I get the y? Go to either one of these equations. I'm going to take the first one. So if x is 3, that means 2 times 3 plus y equals 7, right? 6 plus y equals 7. 6 plus y equals 7. Subtract 6. That's a no-brainer, right? Y equals 1. So the answer to the system, x is 3 and y is 1. You can put the answer in an ordered pair, which is usually the best way to put an answer. And 3 and 1 should work in both of those equations. You can check it if you want. 2 times 3 is 6, plus 1 is 7. How about here? 3 times 1 is 3, right? Minus 1, 3 times 3 is 9, minus 1 is 8. So it checks in both systems. Now, look at the second example. This one's a little trickier. Because if I draw a line and try to add, nothing disappears. Look, 7x minus 6y equals 20. Oh, that's a problem. So I can't do that by adding. There's a trick to these, though. If that was a positive 5y, and then when I added, the y's would disappear. Well, guess what? I can change that equation as long as I do the same thing to all parts. So I'm going to multiply by a negative 5. So I put a note up there. Now I'm going to rewrite it. Negative 5 times 4. Negative 20x. Negative 5 times negative y plus 5y. Negative 5 times positive 9. 45. Now I'm just going to write this equation right underneath it. I'm not going to multiply it by anything. Now do you see something nice that's going to happen? Uh-oh, I made a mistake. Anyone see it? This is supposed to be a minus. Keep me honest here. Hope you're checking my work. All right. Glad I figured that out. All right, now I'm just going to draw a line. I'm going to add just like I did on this first one. So what's negative 20 plus 3? Negative 17x. 5y minus 5y, 0. Don't need to write that. Negative 45 plus 11. Negative 34. All right, let's continue to solve this for x. Divide both sides by 17? No, negative 17. You knew that, right? Okay. So x equals 2. Am I done? No. Let's go back here to the beginning. If x is 2, 3 times 2 is 6. So that would make that 6 minus 5y equals 11. Subtract 6. Subtract 6, I get 5. So negative 5y equals 5. Y equals negative 1. Y equals negative 1. How do I write my answer? Do I leave it like that? No, I get fancy. Put it in an ordered pair. 2, negative 1. Now, it's a good idea. Check both your x and y answers in both equations to see that it works. It has to work in both. If it works in both, you know you have the correct answer. So, there's some examples of solving systems. Good luck with your homework.